Hello and welcome to Scully Unclassified. I'm Scully. I created this channel to teach you the skills needed to be an embedded software engineer with a focus on aerospace. Today's topic, use cases. So you want to make something. Where do you start? Most often we look for a system or piece of software that almost does what we're looking for and then tweak that. What are the changes we can make to that? How do we want it to work different, or what new feature do we want to put on it? And that works really well for an app because you can jump in and get tight iterations. So you can get the next version out really quick. You've already got something that mostly works. You try a new feature or a new layout on the user interface, and you get that in front of your users. You get that feedback, incorporate that into the next version, and that's a system that works quite well. When you have a large, complicated systems that you find often in aerospace, like you want to launch a rocket ship, you could have hundreds of people, dozens of companies, all different computers and boxes on the vehicle itself and the launch system and the ground system, and thinking that you can iterate whole instances of that system, the cycle times would just be too long. You could decide you might blow up every other rocket ship, but you probably shouldn't. Having a more disciplined requirements process will make sure that the interactions are captured. It'll make sure that you have a consistent vocabulary amongst all the people that are working on it, that they understand what the system should do in what order, and then communicate that well. Because from an email or a wiki or something that just gets passed around, if you're looking at when the box will actually be built and ready for integration might be a year and a half away, you should be sure that you have clear definitions of what it should do, clear definitions of what those interfaces are and how they should interact, and that's where use cases come in. So what is a use case? A use case is a series of steps and interactions to achieve a goal. In use case, you want to focus on those interactions. What does the subject of the use case do, and what's its interactions in it? You might know that you have to calculate a certain value, or you need to flip a certain bit, or kind of the low-level nitty-gritty of what that is. But you want to, when you write the use cases, and you write the steps and the interactions in those use cases, the subject is very clear and very consistent. And you don't want to have, in a set of use cases for a particular subject, different levels. In a large system, you're going to have hierarchical design. You're going to have to decompose big things into little things, and the same is true for use cases. So when you're thinking about a use case for the whole rocket ship, think about the whole rocket ship. If you're writing use cases just for the flight software that's running on a computer in the rocket ship, that subject of the use case is going to be very different. So if you have use cases on the rocket ship itself, you would talk about interactions with the launch system, and you would talk about not only the data messages going back and forth, but you would talk about power being applied, certain safety interlocks being applied. When you then go to use cases for the flight software, it does exchange messages with the ground system, and some of those will look very similar. But its actors are, in addition to that ground system, are going to be other boxes within the missile. So the sensor might be an actor within a use case for the software, because the subject of the use case is the software itself. But when you go to a use case where the subject is the whole rocket ship, that's just part of it. And when you're writing the steps in there, you don't want to be too prescriptive about how the things are being done as much as what's being done. Because if you take your use cases and you break it down, you can leverage them for what your architecture should be. And you really want to focus on what needs to be done, not exactly how it should be done. And the what is defined by those interactions with your actors. If your actor doesn't see it, it often shouldn't belong in the use case. So here we have a use case template. And it's important for your project to have a template so the whole team agrees what a complete use case is and the information that a use case should capture. You'll find lots of different templates online, and some are quite large. And you need to remember that each field needs maintenance. So if you have a long-running project that's going to be quite long, these use cases could be around for 20 years. And if you have a particular field on there that needs maintenance or editing, or half the use cases don't even use it, you should consider focusing that in, paring it down. It also helps with the vocabulary of what's in a use case, and everyone agree what that complete use case is. So use case has a title. So associated with that title is the goal of the use case. So I mentioned before that a use case is a series of steps, interactions that achieve a goal. So you want the goal, the use case. The title usually is something shorter than the goal itself. The goal should include the scope or subject of the use case. So is the subject of the use case a rocket ship or a launch system or a sensor? You have the title of the use case itself, you have a goal, and that goal is associated with the subject. Use case has both steps and interactions. So who do you interact with? Use case needs actors. So actors are anything external to a use case. And there's different types of actors. The most obvious one are people that use the system or piece of software. And the actors are organized by roles. Is it someone who does maintenance on the system? Is it someone that's just a user at large? Is it someone who needs to audit the system? And different roles that those users play. And an individual person might be different roles at different times, but the actors are the roles they play. You could also have actors that are external computers, a server, a sensor, something that gets talked to over a network, and it still tends to be roles that, what kind of server is it? Or you might have an actor that's a more general sensor, and you can also have hierarchies of actors. So you can use a generalization relationship between actors, where you might have a generic sensor as an actor, and then you might have a inertial sensor, and that's a generalization of the sensor actor in general. And you might have some use cases that deal with generic sensors, you might have other use cases that deal with specific ones, but you can relate those to each other. And you can do the same thing with some of the human actors. If your roles have that kind of generalization, there's something more general on top, specific coming from it. You could also have actors of things in the environment, not necessarily different computer systems you go to, but when you're interacting with the real world, if you want to make a robot arm that picks up a box, now that box might be an actor within your system, something that's external to it and that you need to interact with. That is, you get steps, you'll interact with you'll have steps within your interactions. Preconditions and postconditions are important for the use case. They are all related to the goal. So before you go into the steps of the use case, you want to consider what state should the system be in for this use case to apply. So if you have a orbital maneuver use case, you would expect a precondition that the vehicle is on orbit. If you have a power-up use case, you might have preconditioned that the vehicle is currently powered down before you power it back up. And the post-conditions are often the state you leave the system in that your goal has been accomplished. So when the use case has completed successfully, here's the post-conditions of what the system or piece of software should be in. You want a trigger for the use case as well. What's the first thing that happens? And on a system that is very user-driven, it's often the user logs in, the user presses a button, the user triggers something, because you want to know what's going to get those steps in order. And then the bulk of the use case itself is those scenario steps. What gets done, and you really want to focus on what's the subject or scope of your use case and what interactions it has with its actors. And you want to keep the scope consistent. The easiest mistake to make in use cases is you jump down too far low level as you're working at the steps. You want to keep the goal in mind, you want to keep the actors in mind, which are interfaces to the system, and what's your overall scope. So if you're writing use cases for the whole rocket ship, you don't want to be too prescriptive about what's inside the rocket ship that needs to do things. So you have the scenario steps of, you have interactions with your actors, sending and receiving messages, what calculations you need to make, and you want to be mindful of what the scope is, what you're talking about, what's the subject of the sentence, and then what the interactions are. And finally, in your use case template, you want to capture what the relationship is to the other use cases. And I mentioned generalization before about actors, and you could have a general sensor actor, and you then have a more specific one that have a relationship to it. Use cases can behave the same way. You might have a more generic interaction, and you might want to then have a specific iteration of it. And some of those might even match what your generalizations are amongst your actors. And you have more general interaction or series of steps, and then you might have a generalization that gets more specific. And don't think you have to have generalizations. Just as you lay out your use cases and you want to communicate for those, it can be a useful thing to have generalizations of use cases to others. You associate your use cases with actors. So you want the actors on the use case are associated with that use case. And the association relationship is really derived from what your list of actors are that you had previously in your template. Use cases can include other use cases. So if you have a common step, you can put that in its own use case, or a common sequence of interactions that multiple other use cases could have. So you can have a breakdown of one use case includes a couple of others, and you could also have two different use cases both include a common piece. So you have that includes relationships amongst the use case. Another important use case is the extension. So you want to handle off-nominal cases within your step. So you'll go through your steps of, you'll first take, say, launch sequence of your nominal steps, you power it on, do a built-in self-test, but you want to be able to handle off-nominal cases like a test fails, or the user wants to abort the flight. And what are the steps for those off-nominal pieces? And these would be extensions off the use case. So you can get down to what's your nominal, or what's the common happy path between the interactions and the steps. And then you could have extension use cases or even extension steps within the same use case to then handle the off-nominal paths. In addition to these use case templates, and you can just keep use cases as Word documents, and people do, but it's a lot of value. I'm a visual person. I do like use case diagrams. And it helps really draw out who the actors are, which actors are common to different use cases, because you draw the associations between the actors and the use case bubbles themselves, and as use cases relate to each other, either as an include or an extend. To see that drawn out in a diagram helps you understand it more. Also, if your diagram becomes complicated, maybe your use case organization is also too complicated. That if you have a lot of boxes and lines, that maybe it's becoming too complicated. And in addition to keeping the right scope, the second most critical thing, or the easiest mistake to make, is the size of each of the use cases. And do you have a consistent size among them? And do you have a use case that's included, for example, but it's only 2 steps? It's not interesting. Maybe that shouldn't be its own use case. Maybe it should be steps within a use case. At each level, like you have a complicated system, you'll also often have a hierarchy of use cases. Each hierarchy, if you've got 100 different use cases, that's way too much to keep in your mind at the same time. You probably need to combine them up and make them something that also can be implemented and demonstrated. So doing iterations on things, I mentioned before, find something that kind of works like it, do an iteration, get in front of your stakeholder. Don't want to abandon iterations. You want to make sure that you're demonstrating and integrating constantly, and use cases can help with that. If you scope your use case into something that can be implemented within a certain time period, you've got a feature you can show off, you can use that use case as here are the interactions, here are the steps you're going to take, we're going to integrate them, and we're going to demonstrate them. So we get those in front of the stakeholders. Are we on the right path? Do we understand? We wrote this use case. We put out steps, we put out interactions, but when you actually implement that, does it do what you want? In old style waterfall, you had series of requirements definitions before you actually implemented everything. Or modern standards, you want to do iterative, incremental processes. So you might not have all your use cases done to the level that you could implement them on, but taking a good set of use cases and getting ones at the right level and working your way down to implementation, the size of your use case should be something that you feel you could put together, demonstrate, integrate, and give value. Let's work through an example of a use case. And let's take launch. So every rocket ship needs to launch. So it's got a subject or a scope of the spaceship itself. It's got a goal that the spaceship is launched. It's got a precondition, spaceship should be off. And it's got a postcondition, that the spaceship has lifted off. And it has steps itself, And this is kind of a high-level use case, so its steps are really going to be included other use cases. So you have the trigger of the external system or the launch system applying external power, and you're going to power up, do a self-test, you're going to load mission parameters, you're going to go to internal power, and finally you're going to ignite the rocket motor. And if you fulfill all those steps, you should reach your goal, and you should achieve the post conditions. And this is a high-level use case, so as we have relationships to other use cases, power up, for example, is its own use case that's included here, and you power up from launch, and it's included from that. Also, if you had another use case for maintenance, you wanted to power up to just perform maintenance on the machine itself or maintenance on the vehicle, you can still have that same power up use case. It's included here from launch, but it would be also included in the other one. We're also going to have relationships to abort use cases here. So that's why you have exceptions and you have abort. Now, if we go to the use case for power on, still the same template. So the title being power on, the spaceship being the subject. The goal is that the spaceship is powered on and can communicate with the launch system. The actor is the launch system itself. Precondition is the same, that it's powered off. But the post condition is very similar to the goal, that the machine is powered on and can communicate with the system on the ground. And now when we go to the scenario steps, really want to focus on what the scope is, what's the subject of it, the spaceship itself, what does the spaceship do as far as the steps go, and what are the interactions with its actors. What are the messages it might send or receive, or how do they interact with each other. So we have the launch system applying external power. The spaceship initializes its subsystem, so you have multiple computers and boxes on there. The launch system connects a TCP socket to the spaceship, and the launch system asks for a status, it sends a status request, and the spaceship sends a response. So notice that it's talking about what the spaceship does. Now you really know there's a computer in there, maybe a flight computer, that's talking to the ground system. And it's the one exchanging those messages. But as I mentioned before, you don't want to be too prescriptive about what that architecture is. You want to say what the subject does, subject to your sentence, should be the scope of your use case, that the spaceship sends back that status request. And then as you use this use case to create an architecture that defines that, you can go into those details there. I appreciate everyone watching. I'd love to hear from you in the comments, requests for different clarifications or topics you'd like me to cover. And thanks for watching.